You probably don't understand how global warming happens. I didn't either. Well, it's greenhouse gases like CO2. They trap heat and cause temperatures to rise. Yeah, but that doesn't really explain how. Let me ask you this. If the Earth receives energy from the sun and it also gives off heat, otherwise the temperature would constantly rise, why does it seem like CO2 only works here? Why does it trap heat only there? What is going on here? Understanding that for me means understanding how global warming works, and to understand that we need to begin with the topic of warming. Any object that receives heat at a higher rate than it gives off heat will warm. The same thing applies to the Earth. Specifically, the Earth receives about 340 watts per square meters from the sun. If 340 meters sounds abstract, just imagine a quarter of what an espresso coffee machine needs to run. So 340 watts per square meter come in and around 339 watts per square meter come out. The difference is about 0.79 watts per square meter. In other words, per 5 square meters, which is the size of a small to medium-sized bathroom, the difference between the rate of heat coming in and coming out is equivalent to what this phone charger uses when you plug it in. Let's talk about CO2 and other greenhouse gases now. Why do they trap heat only here, only on the way out? What's going on here? The short answer is the wavelength at which the sun radiates the energy that reaches the Earth is not the same as the wavelength at which the Earth radiates that energy back out into space. That's a broad statement, but I found this great but complex diagram that explains how it all happens. To understand it, let's divide the diagram into two halves. The first half shows the incoming energy from the sun. This top section shows how much energy reaches us, the surface of the Earth, and how much of it comes at what wavelength. Now, this is important to understand. This top section is not the same as this red arrow that I showed here previously, because that shows how much energy the sun is sending, or how much energy reaches the top of the Earth's atmosphere. Now, because the atmosphere is between the Earth and the sun, some of the energy from the sun doesn't reach the surface of the Earth. It is either absorbed or reflected by the atmosphere. And that's exactly what this gray area shows. The gray area shows what's missing in the orange area. So a gray peak reaching the top of the gray axis means that 100% of the energy was absorbed by the atmosphere at that wavelength. And if the peak doesn't reach the top of the axis, it means that some of it is still getting through and reaching the surface of the Earth. The bottom half of the diagram just shows a breakdown of what gases are participating at what the gray area describes. So we see, for example, that ozone and oxygen absorb all of the energy that reaches us between 0.2 and 0.3 micrometers. The only greenhouse gas that is absorbing incoming energy from the sun is mainly water vapor and some CO2 over here. Water vapor is a greenhouse gas? Yes, it is, but let's talk about that a little bit later. Now that we understand how to read the diagram, let's talk about radiation out, the energy that the Earth reflects back out into space, so we can finally understand what is going on here. This whole right section represents radiation out. The blue area shows what is radiated out into space. And our gray section now shows what we're trying to understand, what the atmosphere does with the radiation that leaves the surface of the Earth. This is where we see the effect of greenhouse gases. Earth is emitting radiation at this wavelength range, but it initially absorbed it at this wavelength range. And CO2, methane, nitrogen oxides, and water vapor mainly absorbed the radiation that is emitted outwards and re-emit it. That's what's happening right here. How do they re-emit it? When CO2 and other greenhouse gases absorb radiation, a sort of energy ping pong takes place. The energy is absorbed and re-emitted by greenhouse gases in all directions. Some of this energy reaches again the surface of the Earth, where it is absorbed and re-emitted, then absorbed and re-emitted again. Absorbed and re-emitted, absorbed and re-emitted, absorbed and re-emitted. Important though, only some of that heat that is being absorbed is being re-emitted downwards towards the Earth again. It's like if the energy ping pong ball would get smaller and smaller every time. And that's what causes the difference in the rate of heating and the rate of cooling in the Earth. The energy ping pong caused by by greenhouse gases causes the rate of cooling to slow down, thereby increasing temperatures. Okay, what about the water vapor? It turns out water vapor is the Earth's most abundant greenhouse gas. The effect of water vapor is, however, indirect. What does that mean? So the more of the other greenhouse gases we emit, the more temperatures will rise, causing more water to evaporate and thereby increasing water vapor in the atmosphere. Other questions we may have about CO2. Why do we always talk about CO2 when there's obviously other greenhouse gases? When we're talking about greenhouse gas emissions, it is useful to think of greenhouse gases in terms of their global warming potential. To compare all greenhouse gases in terms of their GWP, we use carbon dioxide as a common base. So, for example, the GWP of methane is 25, and that means that 1 ton of methane is equal to 25 tons of CO2. So, although we mainly hear or read headlines about CO2, what is generally meant is all greenhouse gas emissions. And now to finalize, something that blew my mind: how much of these greenhouse gases actually compose our atmosphere? It's less than 0.1%. That's crazy, and that just illustrates how sensitive the Earth is to these type of emissions. So we have clarified the mystery behind the radiation that the Earth emits, how greenhouse gases only get absorbed at certain wavelengths, and that this absorption of heat leads to a decrease in the rate of cooling, leading to a difference in the rate of heating and cooling, and therefore causing warming. And now we finally understand how global warming works. Thanks for watching.